Okay, for lesson 3.6, what happens is they like to discuss the difference between three types of functions: linear, quadratic, and exponential. Okay, so first function that they're going to talk about or review is a linear function. Some keywords we need to remember. What is the rate of change? Again, rate of change is basically your slope, right? We like to say that this is a change in y over the change in x, which allows us to get an average rate of change, which is basically how we calculate slope, which is y minus y over x minus x. But when you subtract, you have to keep in mind, you want to keep the order the same when you subtract, okay? So right now, there are three forms of a linear equation. Standard form, which is ax plus by equals c, where a, b, and c are real numbers, right? And an example of this is 3x minus 2y equals 7. Notice x and y are raised to the first power. Okay, so there's no exponents on x and y. Now, slope-intercept form, right? What we have here is y equals mx plus b, where m is the slope and b is the y coordinate of the y-intercept. Okay, so they give you an example of what that would look like below. Then point slope form, right, is y minus y1 equals m times x minus x1. What you have to understand, x1 and y1 represent a point, right? So that would be a point, and m is your slope. So m is the slope, and x1, y1 is a point on the graph. Okay. Now, if you have a linear function, right? What are some graphical characteristics of a function? If m is greater than 0, it shows you basically that the graph is increasing like such. All right. If m is less than 0, we basically say the graph is decreasing, meaning you're basically walking downhill. Okay. If the absolute value of your slope is less than 1, right, it's basically going to be a line that is not very steep. Okay. If its absolute value of m is greater than 1, then the graph is steep. Okay. If b equals 0, right, that means the graph goes through the origin, meaning the point 0, 0. So that would look like this, where your y-intercept is the origin. If m is equal to 0, that means you have a horizontal line. Because if you're not walking uphill or downhill, your slope is 0. All right. So as we look through here, a blank shows how two quantities are related. Okay. So we say a rate of change shows how two quantities are related. For a linear function, right, meaning a straight line, the rate of change is the same as the slope of the line. Linear functions have a constant rate of change, meaning your steps will always be the same. So slope is basically your rise over your run, or your vertical change over your horizontal change, which is your change in y over your change in x. So you would get y2 minus y1 over x2 minus x1. Now don't let those little numbers mess you up. It's just basically telling you the order in which you subtract is important. Okay? So the rate of change for a linear function is the same as the slope. There's 3 ways to find the slope, right? You could basically do it, from the graph using rise over run. Okay? You can use the formula with two ordered pairs where you subtract the y's over subtract the x's, or you can identify it from an equation. So if you were given y equals mx plus b, your slope would be the value of m. Okay, so the following table below shows some aspects of a quadratic equation. Complete the column on the right. So when you look here, right, what you have to understand is this is the quadratic formula. And they're basically telling you that you're finding the value of x that makes the equation equal to 0. Therefore, this represents your x-intercepts. So if you were to graph it, and that parabola would go through the x-axis here and here, these would represent your x-intercepts. Okay? If you remember, the opposite of b over 2a says the x-coordinate of your vertex is the opposite of b over 2x. So that represents the x-coordinate of the vertex. And 0c, anytime you have an x value of 0, you know that represents your y-intercept. Okay? Now, what does the standard form of a quadratic function look like? Okay, so this would be ax squared plus bx plus c. So anytime you have an x squared term, and it's ax squared plus bx plus c, right? That's going to be a quadratic function in standard form. Okay, a quadratic form in vertex form, that's going to be your y equals a times x minus h all squared plus k. And factored form would just be some number x minus some number times x plus some number, right? It could be plus plus or minus minus, it doesn't matter. So if we had to look at this, it says use a table on the left to help you find the average rate of change for each interval of this quadratic function. Okay, now when we look at that over the interval from 0 to 1, this average rate of change is you went up 2. Over the interval 1 to 2, from 1 to 2, this went up 6. Then it goes up 10. Then it goes up 14. And then it went up 18. Okay, so it says use the table, right, of a different quadratic function to find the average rate of change in the interval from 6 to 7. Okay. From 6 to 7, right? Here you went up 5, you went up 5, you went up 5, you went up 5, right? So the average rate of change for the next one would be 5, or sorry, from 6 to 7. So if we continue this pattern, 5 to 6, and then 6 to 7, we know it's going to go up 5 here, which makes that 28, and you know it's going to go up 5 more to make it 33. So the rate of change is 5, but the value would be 33. Okay? So the next one, what is your average rate of change for this quadratic function for the interval 1, 2, 3? So when I go from 1, from x value of 1 to an x value of 3, right? We went from 1, 3 to 3, 10. How would I find this average rate of change? I'm basically finding the slope of the line between the 2 points. So I would say the average rate of change, the average rate of change would equal 10 minus 3, so y minus y, over, since I started with 10, I must start with 3, minus 1, and this would give you 7 over 2. All right, and remember that's subtracting the x's. Oh, sorry. Oh, this is 1, 2. Sorry, not 1, 3. So 10 minus 2, which is 8, over 2, which gives you an average rate of rate of change of 4. Okay. Next one. What is the average rate of change for this quadratic function for the interval 6 to 8? Right? So if I look, it would be 6, 8. All right. And then it would be 8, 4. So if I was to calculate the average rate of change, right, that would be 8 minus 4 over 6 minus 8, which gives you 4 over negative 2, which is negative 2. So the average rate of change for this one would be negative 2. All right. So next one, exponential equations, right? What you have to understand is what these look like is y equals a times b to the x. All right. Now, if b is greater than 1 and a is greater than 0, your graph increases. So it would look something like this if you were to graph it. If it's between 0 and 1, right, meaning it's a fraction or decimal less than 1 but greater than 0, the graph decreases, meaning it's exponential decay. So it would look something like this. And 0, again, when your x value is 0, you know you have the y-intercept. So how would we use the tables to find the average rate of change for the exponential function, right? Well, what these have is called a common factor. So if you had like this here, from 0 to 1, your average rate of change was 2, right? From 1 to 2, your average rate of change was 6, right? So when I look at this, right, your common difference or your average rate of change from 5 to 6, right, would be times 3, but from 5 to 6, the value would end up being 162 times 3, which is 486. So this kind of represents what we call a common difference, but the average rate of change is what is the average rate of change going up or down, okay? So when you look at example B, okay, so from what is the average rate of change for the exponential function for the interval x equals 1 to x equals 3? So here's 1 and here's 3. It's almost like if you drew a line through it, right? What would the slope of that line be? Well, what is my change in y? So the slope or rate of change is 27 minus 3. Again, subtract the y's over 3 minus 1, and that's subtracting the x's. And remember, do it in the same order. That would give me 24 over 2, or an average rate of change of 12. Okay, so let's look at the checkup. So first question asks, identify the form of the equation and two characteristics of the function's graph. So right away, when I look at it, x and y are both raised to the first power, which makes this function linear. Now from this equation, I can gather that the slope is -7 and that the y-intercept is 0, 2. Now this ends up being the point-slope form of a linear function. So it's linear. I know the slope is this right here, 2/3. And I know a point on this line would be, it would be the opposite of -5, which is 5. And then 2. Remember, when you have x minus 5 here, right? The point slope form is y minus y equals m times x minus x. So when we plug the x value in, we change the sign. So when we pull the x value out, we change the sign. Okay. Number 3. What is the average rate of change, okay, for the quadratic function for the interval from x equals 3 to x equals 5? So again, if we were to graph these two lines and find the rate of change between them, your slope or rate of change would be 26 minus 10, subtract the y's, over, subtract the x's. That would give you 16 over 2, which is 8. So the average rate of change for the function for the interval x equals 3 to x equals 5 is 8. What is the average rate of change for the exponential function from the interval 2 to 4? Well, if I go ahead and look at this, right, all I'm going to do is find the slope between those 2 points. So 256 minus 16 over 4 minus 2 will give you 240 over 2, which is 70. Or sorry, excuse me. Sorry about that. Which is 120. All right. So right now, what is the average rate of change for the quadratic function for the intervals 0 to 2? So right away here from 0 to 2. So we have 0, comma 1, and then this ordered pair is 2, 5. So you know your average rate of change would be subtract the y's, 5 minus 1, over subtract the x's, 2 minus 0, That'll give you 4 over 2, which is 2. Okay. Next, what is the average rate of change for the exponential function from 2 to 4? Well, you have ordered pair 2, 4 and 4, 16. What is the slope of the line between those 2 points? Well, 16 minus 4 over 4 minus 2 would give you 12 over 2, which is 6. And it says, use the pattern shown in the tables to predict the average rate of change for each function. All right. So these tables represent a quadratic function with a vertex of at 6, 8. What is the average rate of change from 14 to 15? Well, you know it's going down 2 each time, right? So if you look here, the average rate of change from 12 to 13, that would be go down to negative 13. Then from 13 to 14, go down to, and again, that'd be negative 15. So then when you go 14 to 15, it would be down 17. So your average rate of change here would be negative 17. Okay. For the next one, your average rate of change over the interval, right? You're multiplying by 2 each time here. Okay. Oh, sorry. So if you're multiplying by 2 each time from 8 to 9, so from 7 to, or sorry, from 6 to 7, right? Multiply by 2, that'd be 64. From 7 to 8, that would be 128. Multiply by 2 again. So 8 to 9 would be 256. Okay. So number 9, identify the x-intercepts, the y-intercept, and vertex of the quadratic function. Right? How do I know it's quadratic? Because my exponent is 2. So real quick, the easiest one to find is the y-intercept. And your y-intercept is just going to be when x is 0, 2 times 0 plus 14 times 0 plus 20 is going to just be 20. Now, your x-intercepts, right? When we look at this, we're going to basically go and use the quadratic formula. So I have to go ahead and find the discriminant. So b squared, 14 squared minus 4 times 2 times 20 is going to give me 36. So now when I plug this in the quadratic formula, the opposite of b, negative 14, plus or minus the square root of the discriminant, 36, all over 2 times 2. So this is going to break up into 2 problems. Negative 14 plus 6 all over 4, because the square root of 36 is 6. The second one would be negative 14 minus 6 over 4. So your x values would be negative 8 over 4, which is negative 2. Then negative 20 over 4, which is negative 5. So your x-intercepts would be negative 2, 0. And the other one would be negative 5, 0. Then last, your vertex. I'm going to basically find the x value of the vertex using the opposite of b over 2a. So if b is 14, the opposite of is negative 14 over 2 times a is 2. And that's going to give me negative 14 over 4. Now, if I simplify that, that would end up being negative 3.5. And if I plug that back in to the function, right, what would the y value be? So if we plug that back in, the y value would be 2 times 3.5 squared plus 14 times 3.5 plus 20 would give you a y value of negative 4.5, which means your vertex would be negative 3.5, negative 4.5. Okay, now the next one, for the function y equals 3 times 3/4 of x, identify the y-intercept and determine whether it's increasing or decreasing. Well, if I let x equal 0, right away, if x is 0, y would be 3 times 3/4 to the 0. Anything that is 0 power is 1, so 3 times 1 would be 3. So right away, your y-intercept would be 0, 3. Now, because if I look, this value being raised to the x power, since that's between 0 and 1, 3/4 is greater than 0, but less than 1. Since that's between 0 and 1, we know it's exponential decay, so it is decreasing. The graph would start high and come low. All right. Hope this helps. Go ahead, try the quiz, and let me know if you have any questions.